So I'm doing something a little weird. I was trying to make a video for you and my software isn't working. So I thought, well, I'm kind of itching to make the video, so let's just do a live video. Why not, right? So I'm doing a video on finding the vertical asymptotes of a tangent function. They ask us specifically to find the vertical asymptotes of y equals tangent theta minus pi over 4 plus 2. So the first thing we're going to do, sorry, I'm having issues with this backwards view. Okay. The first thing we're going to do is look at the graph of tangent theta, okay? Okay, so if we're just looking at tangent theta, right? Not this whole thing. Okay, the graph will have asymptotes at negative pi over 2, negative 3 pi over 2, pi over 2, 3 pi over 2, okay, and so on in each direction. Okay, let's just say 2, 4, 6, 8, 10, doesn't really matter. Okay, so we're gonna have asymptotes here. And then the graph itself, hold on, let me see if I can get another color in here. So what it does is it crosses and then goes up the asymptotes, okay? It can never cross, that's what an asymptote is about, right? Something like that. Sorry for my drawing. Okay, so it crosses, but it never touches those asymptotes, okay? So we have an equation that explains to us the asymptotes of the function, okay? And that is pi over 2 plus pi times k. It's pi times k. So that always gives us the asymptotes of the graph, okay? So when we look at this equation, what we're going to do is we're going to find out the phase shift. So we're going to find out how much to the right or to the left that this is going to move. We don't actually have to graph it, but if we do that, we'll be able to tell where the new asymptotes are, okay? So what we're going to do and we're going to do it actually, we're going to keep it in terms of k, okay? We're not going to use any actual numbers here. That's why we don't have to graph it. Okay, so we're just going to look at this and we're going to try to figure out what the phase shift is, okay? Now, the phase shift in these tan functions, you just take this part on the inside, okay? And you set it to 0, okay? And you solve for theta. So we have theta minus pi over 4 equals 0. Okay, so theta equals pi over 4. This pi over 4 right here, that's our phase shift, okay? So it's going to move to the right, pi over 4, okay? So to find the asymptotes of this equation in terms of k, where k is the period, all we have to do is add pi over 4 to this whole thing. Okay, hold on, sorry. I'm sorry, it's giving you guys the wrong equations. Okay. You have to add pi over 4, sorry, to the asymptote here. Okay, this is the asymptote equation. This pi over 2 plus pi times k. So we're going to add pi over 4 to that whole thing. Okay. Sorry, I'm having a hard time writing this way. Sorry, I'm trying to write legibly. Guys, let me know how this is working out, because I will not do this again if it's too hard to see, okay? So, here, I took this original equation for the asymptote, oops, okay? And we added the phase shift to it, which was pi over 4, okay? And that's what I have down here. I have this pi over 2. We keep that plus, actually it's plus or minus, okay? Because we can go on the left side of the equation as well. So plus or minus pi k plus pi over 4. I just changed the denominators there, and then I get 3 pi over 4 plus or minus pi times k, okay? And that's going to give us, in terms of k, the number of periods where the new asymptotes are. So they're just gonna, this whole thing is going to shift. All of these lines are going to shift, okay? Pi over 4 to the right, okay? Thank you for watching. Sorry for the weirdness and the abruptness. Hopefully it was clear enough. I didn't want to kind of go too long without giving you guys a video. So I will post the next one soon, and I'll see you guys on Wednesday, the ones that come to watch my SAT class. Thanks, guys.